communities in Costa Rica, and the agriculture sector and the government were unprepared to deal with flooding and droughts. So they have a lot of losses, but they work more in reconstruction and dealing with emergency than planning and risk prevention. So it's very important to help our country in these areas to reduce these losses.
Hi, I'm Stephanie Tomampos, and you're listening to Down to Earth, the show where we talk to incredible geoscientists about their science and its impacts on our planet. Did you know that Costa Rica is on track to become the world's first carbon neutral country? In 2019, they adopted a plan to reach net zero by 2050. Though the country's efforts won't make too much of a dent in our global temperatures nor our carbon emissions, what this small but tenacious country is doing is carving a path towards a carbon neutral future that other countries can emulate. However, as a country bordered by the Caribbean Sea to the east and the Pacific Ocean to the west, Costa Rica is still going to be vulnerable to dramatic shifts in weather patterns due to climate change. Already, floods and storms have had the highest human and economic impact of any other natural disaster, according to the Climate Change Knowledge Portal. Figuring out how to plan for and recover from these impending disasters is going to be important while Costa Rica waits for the larger, more pernicious climate culprits to catch up on the net zero goal. So today, we're speaking with two remote sensing scientists working to empower decision makers with the data they need to do this planning in the agricultural sector. This season of Down to Earth is supported by the Inspire, Develop, Empower, Advance, or IDEA Committee of the IEEE Geoscience and Remote Sensing Society. The IDEA Committee works to empower engineers and scientists in their geoscience and remote sensing careers by organizing events, activities, and programming for members around the world. One program listeners should definitely explore is their Women Mentoring Women program. This mentorship program is an incredible experience that fosters careers and friendships across generations, disciplines, and geographies. To learn more, visit grss-ieee.org and select IDEA from the Community header menu.
I grew up surrounded of multiple crop farms, from the ones in the mountain to the inshore, where my grandfather had his own farm. He used to have sugarcane and rice. So everything started there. There started my passion for the agriculture and made me realize about the importance of it in human life. And even though I didn't have any previous education at that time, because I was a little girl, I still saw several problems that my family, my grandfather, for example, and farmers around those areas were facing, specifically focused on the management, right, and shortages of resources. So that's why I started getting interested in agricultural engineering.
This is Dr. Melissa Rojas-Downing. She's a biosystems engineer who teaches and conducts research at the University of Costa Rica in the Department of Biosystems and Agricultural Engineering. She specializes in the modeling of food, energy, and water systems with the goal of optimizing agricultural production.
I study agricultural engineering at the University of Costa Rica, and I remember that I acquired my first knowledge of GIS in a soil conservation course when we learned how to represent the land cover, extract characteristics, and apply statistics. It was amazing for me, and it was like I had eyes in the sky. So when I decided to work in my underdegree thesis in hydrology, I wanted to apply the GIS and remote sensing techniques to characterize the watersheds.
This is Dr. Alejandra Rojas González. She wears many hats at the University of Costa Rica. She's an associate professor in the School of Biosystems Engineering, director of the Biosystems Engineering Master of Science degree program, and the coordinator of the Waters, Soils, and Environmental Laboratory. As you heard, Alejandra's specialty is hydrology. She applies her expertise in this area to many different research projects, including work with the government agency that regulates the distribution of irrigation water in agricultural farms in the province of Guanacaste, Costa Rica.
We need a lot of collaboration between institutions, researchers, and universities to obtain better tools to prevent, forecast, and manage all these events. So, the main objective of this collaboration is to improve water management, to be resilient to climate change, have food security, and maintain a prosperous economy around agriculture production. We can achieve it by combining new remote sensing technologies, long term hydrologic modeling, and incorporating climate change scenarios and water allocation models.
Just as Costa Rica is leading the way towards a carbon neutral future for other countries, these two researchers are doing the same for remote sensing. By combining their expertise in agriculture and hydrology, respectively, they're not only devising systems to help decision makers plan for climate impacts, they're also providing a career model and opportunities for up and coming scientists wanting to work in remote sensing. You and Melissa are now collaborating by joining your research expertise in hydrology and crop and livestock production. So, Melissa and Alejandra, let's start with the big question. How did you both start working together?
When I started doing my master's degree in Michigan State, I started working with modeling of crops, modeling of livestock, and I searched for the different strategies for implementing like biodigester, changing type of management in the livestock and changing the type of feeding and so on. And that's why my interest is starting in identifying forage species through remote sensing, because in that way we could obtain valuable information that we could integrate with the modeling in order to identify strategies to adapt for climate change. So I came with that idea from Michigan, and I shared with Alejandra a proposal, that I started developing in Michigan, where I wanted to start identifying different forage species through remote sensing, and find out that Alejandra also started doing some type of similar research, and that she already had the equipment, that she already bought the equipment that I really needed for doing this project. And then thinking about more projects, she told me about her work in the irrigation district. And then I find out that here in Costa Rica, we're very behind on the crop classification.
Yeah, actually, when I visit, for example, the irrigation district, I noted that there were few studies on water quantification, ability, and water distribution. In addition, there was null development in the crop identification and monitoring using remote sensing techniques and their water consumption too. So in 2018, I managed the acquisition of a spectroradiometer and a spectral camera to start research in field spectroscopy in the irrigation district. And we start to work together due to the necessity to determine spectral signatures from different crops in this irrigation district.
And that's how we started with all these ideas, with projects, with applying SAR into our projects. And well, we just started combining ideas and writing proposal together.
This is amazing. This is really incredible. But just to ask a little thing, did you know each other before this collaboration?
We actually met one time before at a conference here in Costa Rica. But at that time, I was a bachelor student, and Alejandra, I believe she was doing her master's degree or PhD degree.
Yes, I agree.
Yes, and she came and she went to the conference to do a presentation. So when I met her and saw that she was from Costa Rica and everything, for me she was like a great example. For me, I wanted to follow her the same way. For example, going out of the country, studying, doing her PhD outside, and hearing all the amazing research she was doing. But that was the only time I met her, and then never talked to her. And then we met back again here in Costa Rica when I started working and at the biosystems engineering department.
Yeah, I can remember that I talked with a lot of students that were presented in this conference. And I always encourage them to go outside to obtain a master degree. And I said, you can do it. Doesn't matter if you don't have enough economical resources. There are a lot of scholarships outside that you can obtain. You only need to have dreams, and follow them.
What are the chances that one meeting at a conference before would lead you to this, to what you have right now? This kind of collaboration together, it's really amazing. And Melissa, I love that you mentioned that Alejandra was in many ways an inspiration for you, kind of paving a potential journey for you to follow. And actually, you both mentioned traveling outside Costa Rica to complete your graduate degrees. Is studying abroad a big deal?
Yes, it's definitely a big deal. When I finished my bachelor here in Costa Rica, it didn't exist having a master's degree in this area or even a PhD. Right now, a PhD is still a little bit complicated to get it over here. So, for many of us here in Costa Rica, it's like a big dream leaving your country to study outside because for us it's very difficult to get like scholarship in order to study. At least that's the way we see it. And still, a lot of students see it that way.
Yeah, it was a novel in Costa Rica.
I decided to fight for it. And it wasn't that difficult as everyone made it sound. So right now, I'm actually encouraging a lot of students trying to do the same thing.
It's really amazing to really just think about this story. That's like the universe aligning. So it's led you to working together as a team. And I want to learn more about the details of your collaboration. So tell us again, what specifically are you working or looking at right now? What's the research goal? And how are you using remote sensing to find answers?
Yes, well, now we are working with a field spectroradiometer to be able to distinguish forage species, which are like the pasture that cattle usually use to be fed. So we're focusing on the forage species that cattle use here in Costa Rica. And now we're merging our knowledge on remote sensing in the side of Alejandra with the livestock production in my side. We're also working on another project using SAR because of the limitation of using optical images here in Costa Rica, because we're in the tropics, right? And clouds are all over the place. So we're trying to use SAR to identify different crop species in the irrigation district. And in this way, we are also merging knowledge in remote sensing, crop production, and also water resources. And the main goal of this project is to do the first step for developing a methodology to develop crop maps for our country by using, it can be a combination of optical and SAR, but mainly SAR. And we're starting in the irrigation district because it's the biggest one in the country, where there are around 30,000 hectares of crop, such as rice, sugarcane, and pasture fields, which are the ones where we're trying to focus right now in our project.
So, how did you decide to approach the methodology for this project on crop species identification?
Um, my first step was to do hydrological modeling to study the ability and perform a water balance to determine the feasibility to expand this irrigation district, its coverage to an extra 20,000 hectares in Guanacaste. This is a big goal, and with the climate change scenarios, it's very difficult for the region. It's like the precipitation will reduce to like 60% in the area, and it's a driest area in Costa Rica with almost 6 months of dry season. The water is very, very important, and principally in the future. Um, the objective was to monitor and calculate high resolution actual evapotranspiration using Landsat images and applying an energy balance to calculate net radiation, soil and air sensible fluxes to obtain the actual crop evapotranspiration.
I just want to quickly interrupt you, Alejandra, and ask you to define evapotranspiration before we go further. Can you explain to us what this is?
The evapotranspiration is the amount of water that the plant is taken from the soil and put it into the atmosphere. The health of the crops can vary this evapotranspiration. And one important aspect to quantify the consumption of the plants is the evapotranspiration. If we know this actual evapotranspiration is to know how much water we need to put in the fields.
So the higher the evapotranspiration, or rather, the more water the plant loses, the more water the crops need. And by tracking this, we get a sense of a crop's water balance, which can be linked to crop productivity, right?
Mhm.
Okay, great. Sorry to interrupt, but I think we needed that explanation to fully understand what you and Melissa are trying to do with your research. So, you mentioned that you're using a field inspector radiometer to identify and distinguish forager species. You're using SAR to identify different crop species in the irrigation district, and then you're also combining Landsat images to monitor and calculate evapotranspiration for these crops. What's the ultimate goal of this work?
Yeah, of course. The goal is to have a platform, a web-based platform, when you can monitor the health of the crops, the health of the environment. Actually, I generate a GIS platform called Intelligent Support System for Water Resources Management to show the results and help decision makers to improve distribution and water management and help the agricultural sector to see what is happening with their crops. Still, the administration of the irrigation administration doesn't have efficient verification and quantification of production. So the combination of multispectral images with radar provide us opportunity to solve these needs, even if there is a cloud cover, which is very common in tropical areas. And the radar implementation help us to determine the soil moisture and detect overwatering or flooding problems that affecting the crops. And in the future, this will allow to prioritize the emergency actions and the management of the irrigation district.
Building such an ambitious platform is certainly going to take a lot of resources. Melissa and Alejandra are going to need funding, partnerships with key players, and more researchers with the capacity to support this work. After the break, we dig into exactly how they are consolidating these resources and carving a path for future researchers to follow their remote sensing dreams. So, stay tuned.
Close your eyes. Take a deep breath. I'm going to ask you 3 questions. First, who is your favorite scientist? Someone alive today who is smart, accomplished, passionate, and knowledgeable. Can you picture them? Now, if your favorite scientist is a man, tell me, who is your favorite woman scientist? Last question. Who is your favorite woman scientist in your country? If no one comes to mind, then maybe that person should be you. Help make an impact on a woman's career by joining the Geoscience and Remote Sensing Society's Women Mentoring Women program today. To sign up, visit grss-ieee.org and select Idea from the Community header menu.
Welcome back. Today we're speaking with Dr. Melissa Rojas-Downing and Dr. Alejandra Rojas González, both of whom are researchers and teachers working at the University of Costa Rica. While these researchers only met once at a conference way back when Melissa was still an undergraduate student, that fateful meeting was the catalyst that eventually sparked their recent collaboration. Today, they are working together on several different projects. The first is distinguishing plant species that foragers like cattle eat. They're also identifying crop species in the irrigation district, and they're working together to monitor and calculate evapotranspiration for these crops. The ultimate goal of this work is to create a platform similar to the intelligence support system tool for water resources management that Alejandra created already. This new tool will help decision makers monitor the health of crops and forager environments, and will also help them plan for any potential risks like floods or drought that could impact these precious resources. Melissa and Alejandra have only been working together since 2020, but what they've been able to accomplish so far with their collaboration is certainly impressive. Of course, they still face barriers for these projects. Funding isn't easy to come by. There are not as many skilled remote sensing researchers available to work on these big projects, and collaboration across various governmental and non governmental sectors is still lacking. However, this dynamic duo is tackling these barriers one step at a time. Take a listen.
We're practically in baby steps. It takes time to be able to develop all this. We're practically right now doing projects to prove concepts that we can actually use remote sensing applications in order to, obtain the information we're searching for. So we hope that with this concept research, we can find funding in order to start doing this crop classification all over the country, not only in the irrigation district, but all over the country. And from there on, start using like the platform that Alejandra already developed, combining all the information she's also obtaining from remote sensing, like evapotranspiration, soil humidity, and so on. Combine all this crop type of crops, crop management, and many other information into this website that farmers could later use in order to take decisions.
You mentioned funding. Do you have challenges in acquiring funding for this project?
Yes, that's why we're trying to prove the concept in order to find funding. We can apply here at the university for different types of funding. One is like ordinary funds that are less than $4,000 per year. Then another one is like a supporting type of research fund that is around 15,000 per project, and other type of funds that are involving other universities. At least three universities needs to be involved, and it's about 45,000 per project. And another way is to find funds to perform collaboration agreements with public institutions. But as you can see, the funding is pretty low compared to what we actually need to be able to perform a complete research in the field. But that's why it's important for us to consolidate with different groups and other universities, even at international level, to be able to apply for international funds and support it in a better way, our research.
And are you finding success when it comes to forming collaborations with other universities and organizations?
Yeah, I found some collaborations from the national institutions, for example, from the Emergency Management Commission, from the National Irrigation Service, and they are very, very excited to develop. And right now, we have an extension of our agreement with the Emergency Management Commission for another 3 years too. The idea is to consolidate a research group and incorporate more universities and a remote sensing team from different labs, because to pursue a crop monitoring system is a big step, and we need to establish this kind of alliances with the agricultural sectors, the universities, and the environmental ministers too, and different national institutions that want to work in this idea. So we can put together in our research, and we can obtain more opportunities and add more people to our team to advance more quickly in these steps.
That's incredible. I mean, your work is pulling together a lot of different collaborators. So you're knitting together a big network. And hopefully, this will support both your research as well as the work of other researchers across Costa Rica and hopefully internationally as well. That's definitely what we need all over the world in order to address the very real impacts of climate change, especially in relation to food security. Now, I want to ask about, say, as professors, how are you both supporting the development and engagement of new researchers in the remote sensing and GIS field?
One of the courses that I teach is teaching the students how to develop research proposals. And I have been motivating the students to keen into remote sensing by sharing with them the projects that Alejandra and me are working, and also sharing with them the plans that we have with all these projects and different applications of remote sensing. And because of this, we have now 7 students that are either developing a proposal in remote sensing or already performing their research for their licensure thesis.
Yeah, the SAR technologies and the remote sensing techniques that we apply to evapotranspiration, land allocation, the distribution is very intimidating for them. But we encourage them to try to advance in these topics in remote sensing, and we encourage it to take, for example, RSET courses or other training through the network that we have. But we have also already 7 students, most are women, and they are working very hard because they only receive one course on geomatics and very low level remote sensing. So this is a great effort that they need to take to pursue their thesis.
You mentioned specifically that most of your students are women. Why is this a big deal?
This type of engineering, it was mainly an interest for men. When I studied, we were only 3 women in our class and in our generation, from like about 30 students, right? From 30, 3 women. Now we're having more women interested in biosystems engineering. Now it's practically half and half. That already excites us a lot. It's very exciting for us to have that amount of women.
Yeah, when I study, we have only 2 women in my generation. So for me, it's very, very impressive to have half and half of women in our program right now.
So I understand that there are so many challenges and there's so many obstacles, but I guess your journey is just an example of how much you've also succeeded in this field. Having yourself in this position is already a success story. So what have you learned from your journey so far that you want other people and other scientists to know? What advice would you like to share?
Well, I personally feel that I'm still in baby steps in order to succeed in my current passion, that is remote sensing. But just knowing that there is someone as passionate as me, like Alejandra, that makes me feel empowered to search for better opportunities and think big. I am sure if we keep the passion, we can succeed even higher of what we have dreamed of. I also would like to share with other scientists that when things gets complicated, just don't give up. There is always a way to pursue your goal, and the right people, funding, opportunity, however you want to call it, will show up at your door at the right time. This means work, connect with people from different fields. This will open a lot your mind. Apply for opportunities outside the country. Don't let the lack of funding or support stops you from pursuing your goal. So just keep on going. Research can be done.
When Melissa came with this passion and remote sensing, we immediately made a click. and that encouraged me, knowing that we could support each other, right? So I encourage my students to apply for opportunities outside Costa Rica. And I say them that working with others from different fields is very gratifying, and the knowledge acquired is great, right? This kind of effort put you in another level. You can pursue your dreams, and you can see that the limit is the sky.
Well, that's all for this episode of Down to Earth. Want to learn more about the work being done by Dr. Melissa Rojas-Downing and Dr. Alejandra Rojas González? Then check out the website SAGIR. That's spelled sagirh.ucr.ac.cr. You can also find out more by visiting the website for the Department of Biosystems Engineering at the University of Costa Rica, or by searching for them on ResearchGate. Don't forget to follow us on Spotify and Apple Podcasts. And send some love to our sponsors at IEEE_GRSS on Twitter and Instagram, and IEEE Geoscience and Remote Sensing on Facebook and LinkedIn. This episode was produced by Nicole Bedford from Nicole Bedford Films, with help from me, Stephanie Tomampos. Graphics and design by Mylene Briggs of Killam Media. And a special thanks to Heather McNairn and Sean Kefauver for their support. I'm Stephanie Tomampos, and you've been listening to Down to Earth.